Okay, we're going to look at irrational equations now. That is an equation with an irrational term. An irrational term being something like the square root of 3, which can be written as 1.732058, so long as you keep going on, and it does go on and on. So it's a term that cannot be written as a ratio or as a fraction. So it's either written as this approximation as a decimal or as the square root in this case. So an example of this would be the square root of 12x equals 3x plus 1, and the square root of 12x is your irrational term. So step 1 in this case would be to get rid of the square root. And how do we do that? Well, the opposite of a square root would be a square. So we'll square both sides, the entirety of both sides, to keep it even, and that will leave us with this here, 12x equals 9x squared plus 6x plus 1 if you expand the right hand side. We'll now make that equal to 0 as we normally do with a quadratic equation, and then we'll solve it. Right, so you don't have to factorize it first, you could use the quadratic formula, but if I factorize it, I get, in this case, the same bracket twice. It means that there's only one answer to this, x equals 1 over 3. Right, I'm just going to test this answer. By test, I mean I'll put it back into the original equation just to make sure I've got the right answer here. So the 12 times x square root equals 3x plus 1, and I'll just change x for 1 over 3, which we said was the answer. Plug it in, square root of 4 equals 2, yes it does, so that answer is correct. I'm going to do another example here, it's slightly trickier, and we'll see why. So I'm going to square root, I need to get the square root on its own first, and here's why. If I go ahead and just square both sides as we did in the last example, if I square both sides, I'll get this, written in 2 brackets, just to be explicit about what we do, which is 9 squared plus 3 times root 3x plus 1. We'll have another one of those. And that square root will cancel off, which written in its simplified form will look like this, and we've still got an irrational term. So because we didn't get the square root on its own, we didn't get rid of the irrational term, and we're back where we started. We haven't made any progress towards an answer. So we should first of all get the square root term on its own, and if we do that, we can eliminate all the square roots. Right, so first of all, I'll get the square root all by itself. So I'll move the 3 over to the other side. Now I have got the square root on its own. The next thing I can do is square both sides as we did in the previous example. Alright, so I've squared both sides. I'll just expand that out. I'll get it all equal to 0, so it's ready to be factorized. This is just your general form of a quadratic equation, the ax squared plus bx plus c. Let it equal to 0 so we can solve it. You don't have to factorize once again. You can, but you don't have to. Factorize will be x minus 8 and x minus 1. Now it's important to realize that when we squared both sides, we weren't exactly keeping the equation the same. If you do the same thing to both sides, it does stay equal, but we have altered the equation just a little bit. So now that I've solved the equation, I need next to check my answers. So I'm going to do this. I'm going to take the original equation, 3 plus 3x plus 1 equals x, and I'm going to substitute in the first value, x equals 8. So if I put 8 into the equation, that is 3 plus the square root of 25 equals 8. 3 plus the square root of 25 is 5, so 3 plus 5 equals 8. This is true. I'll do it again with the other answer, x equals to 1, and that's 3 plus the square root of 4 equals 1, so 3 plus the square root of 4 is 5 equals 1. No, that's not true. So what we've done is we've got 2 answers, and only one of them actually works. Because of the square root, we squared both sides, and in doing that, doing that, we've excluded one of the false answers. So the first step would be to get the square root all by itself, so that we can make progress. Then square both sides. Then we write it as a general equation, solve it, check both your answers in the original equation, and then get rid of the false ones.